Okay, hello everyone. So I'm glad to be back after the first OffensiveCon. Yeah, to be here again. Yeah, the talk's about eSIM, embedded SIMs, attack surface implications. I'm Markus Vervier. I would say I'm a generalist, which might reflect in the talk. So I like to look at different things, different technologies. In my day job, I run two companies, Psi, Ready-Made Virtual Simulation startup, and X41, which is more an AppSec pen testing. That's basically what I do, and yeah, but I mostly manage things. So I was glad that I could find some time to actually do some technical work, which is always nice to, because that's what motivates me. So how did it come to this talk? So the talk started actually in a discussion with some colleagues about, does the world need another C2, right? Is that actually something that's needed, right? Because we see this cat and mouse game all the time, that we have some C2 having new obfuscation techniques, but the thing is, it all uses more or less the same transport mechanism and the same sort of transport network layer, and the EDRs are looking at that. So at one point, I got like a new phone, and it has an eSIM, and it was super easy to deploy, right? So, and that actually, got me thinking, like, does the world need another C2? And that's actually where the rabbit hole started. So you see Alice here, that's sort of me. And so I dived into the world of eSIM. So what is actually eSIM? Seems to be everywhere in all the devices, in laptops, in phones, embedded devices, but it seems to be still evolving, right? So it's sort of the same as we have seen before. So you have like a lot of research in SIM cards, UICCs. There were really good talks about SIM toolkit and like remote SIM attacks and M2M security, also even eSIM, and of course hardware, people doing hardware. So all of these, by the way, they were very helpful. So it's not, let's say, I'm invented the wheel here, right? So I actually did some previous research in 2015 on, that's a long time ago, and I sort of implemented actually a kind of eSIM by patching a baseband of a MediaTek device and virtualizing the SIM card, right? And the idea was to like proxy, to do a relay attack on the mobile network, which actually worked, right? It's kind of nice because, back then the SIM cards, they were all physical, of course, and that was by design, and I didn't want that. So a few years later, apparently they discovered it's a good idea, you can sell that. So now we get eSIMs. EUICC is actually the correct name for the actual chip or device, right? So it's like embedded universal integrated circuit, and it can come as a SIM card like you know it classically, but it's also embedded. So MFF2 is normally the form factor, so it's like soldered into the device. And since it's stored into the device, you have to remotely manage and provision it, and can, of course, be remotely programmed and managed. So what are the marketing features here? Of course, flexibility, the network carriers, that you can change them without really physically changing the cards. You can eliminate the need for physical cards. You have smaller devices and connectivity everywhere. Everything's great and flexible. Of course, there's still the similar security concerns like before, like is the data private that's transmitted? What about unauthorized access to the mobile network? That's a big concern for the mobile operators. Of course, they don't want any cloning or spoofing. So if you have an eSIM, like a physical SIM, you shouldn't be able to like deploy the same SIM on multiple devices and paying only once, and any kind of fraud or, of course, the attacks against the device. And that's why they also implemented, and we will see, took a lot of effort to like lock down the system, so they're still in control. So it's not that all control is lost, right? So for clarification, eSIMs can come in two varieties. The M2M one, it's a bit older, introduced 2014, the first specs I found. SGP02 version 4.3 is the current one. It's mostly intended for industrial automotive, and they're actually you're a bit bound to one vendor usually. So you have an eSIM, but it can update profiles and update the data on the SIM, but it's not intended to, let's say, use multiple profiles from different operators, for example. And then there's like a consumer one, which is a bit more recent and still evolving, and that's what, for example, you have in your iPhones or now in this laptop, and that's more open to the users can, for example, subscribe to different operators and have different profiles. So we focus actually on the later ones, right? Because yeah, that's newer and it's more flexible, and yeah, you can. There's some scenarios that are interesting for us. You will see for offensive people. Okay, great. That's visible. I was a bit worried. So this is actually an eSIM as it is described in the spec. That's only basically the chip and what it does to the outside world. So it's a SIM card. I'm not sure if you know about SIM card operating systems a bit. But the modern ones, they have like different security domains. They have like, yeah, they are isolated from each other. And these are also used to implement the eSIM, right? So if you, yeah, pointer doesn't work, but okay. Yeah, we will see it. I won't go into all the details because, yeah, you will see in the kind of the next slides, which doesn't show for some reason. Okay. How complex that actually is. But first of all, I mentioned eSIM profiles. So eSIM, physical SIM cards, yeah, we buy a SIM card, you have telecom, you're on a telecom network. They are multi-SIMs, but yeah. Now you have profiles. So profiles are like a virtualized SIM card, sort of. You have like a digital equivalent of a SIM card, physical SIM card, and they contain the information needed to connect to the device to the cellular network, for example. So you can store multiple of these profiles on your EUICC, or commonly that's what they also call eSIM, but you can only use one at a time, unfortunately. I think I've seen a device dual SIM that might have be able to do two, but that's also like a, let's say, restriction from the hardware, because you can, you only have one radio usually. So, an interesting thing is they can be remotely provisioned, enabled, disabled, and that actually, since, as I mentioned, it contains the keys, for example, to connect to the network, needs to happen securely. So, question is, what does this have to do with C2 and red teaming, right? I mean, might be interesting technology, but I mentioned red teaming. How did I come to the eSIM from red teaming and from offensive security, right? The interesting thing is that the eSIM provides us an out-of-band channel if we are able to deploy it, right? So instead of using, let's say, the network that's provided by the targets, we bring our own network. And then now the question is that actually a realistic thing, right? What is required to provision an eSIM? Can anybody do that? What can you do? Can you use it? How can you customize it? Who implements actually the stuff that's running on it? And yeah, that's how it happens. So it's a vast thing to research because there's so many, let's say, layers. You have like the host operating system. There's a ton of new services managing this eSIM. You have the actual security on the chip. You have the profile provisioning, which is like involving a lot of protocols and mechanisms. So yeah, everything everywhere all at once. But I started looking at the provisioning because I thought like, maybe I can just find some problem in the provisioning, right? It has happened before. The protocols, algorithms are maybe not that designed, well designed, or there's some scenario that's just corner cases that we can exploit. So they looked at provisioning. So okay, how are actually the profiles for an eSIM provisioned? There are two main ways. It's a device can sort of has an EID, and that based on that EID, it can discover a profile on an operator server. I'm going very high level here because you can do a talk on each of the components alone. And that's the interesting thing, consumer, you can enter an activation code or scan a QR code, right? So yeah, how does this QR code look like? For example, that's an example for provisioning a QR code or activation code. So you can basically install the eSIM profile using that code. Or if you scan the QR code, and the Android and iOS phones in the camera app, they recognize that, and it's like super easy to deploy. So you can install it in, I don't know, 30 seconds or less even. So yeah, besides the QR code, so what's actually inside? What do we see here? So inside the QR code, you have an activation code. Yeah, it's a scheme LPA. And then the one is, it's in the spec. I think it's a SIM card slot or something. And then behind the dollar sign, it's the actual host name of the remote, of the provisioning server of the backend, SMDP plus. And then the last point is actually the a kind of secret activation token. Some people have researched into this. Of course, obviously, if this token is not random, you can steal other people's profiles. Actually, didn't check for that. Maybe I should. How they actually generate it, because we can, and we will see later. But that's basically what's in the QR code. So the problem is that the whole process is tightly controlled by the GSMS alliance. And of course, for good reason, they contain operator secrets, right, on the keys alone. And the thing is just that if you have, of course, enough money, you can just buy access, or you run your own, or get certified. But what about us researchers, right? That's a bit of a problem because we cannot just provision an eSIM profile. That's part of the process or part of the infrastructure according to the specs. So the EU ICC is what I showed in the previous slide, only this part, and then there's an SMDP plus. It's like the thing that is managing and has signing and provisioning the key, the eSIM profiles. There's a ton of other things. Then there's the EUM, which is the manufacturer of the eSIM. Then you have the operator, and all are involved. Only the user has not really control except for entering the code, right? So you cannot just add, well, even uninstalling or even activating an eSIM profile involves all of this, right? You need to talk to the backend, so you need to be online. So that's a bit too bad, right? Because you cannot really, if you want to test the device or so, you cannot just install or look at the profiles, and you need to be certified. And yeah, they can be remotely managed actually if you got the keys, but you need the keys. So what is an SMDP plus? SMDP plus is, I'm talking from my not knowing anything perspective, looking at it, right? So for me, it's an HTTPS service, and it is having like a certificate issued by the GSM Association. And the interesting thing is that it has access to end-to-end keys, and it can actually talk directly to the SIM card, right? If you see that in the middle, it's a bit small. In the middle, it's basically EU ICC to SMDP plus. There's an end-to-end encrypted channel. So the device, you have full control, you cannot really intercept that. Yeah, and the secret keys, they are actually stored in the SIM card in a special security domain, ECASD, which you shouldn't have access to. Of course, if you have some bugs on SIM cards or so some other access, yeah, then you can man in the middle of that. Otherwise, no. And the SGP22 is a spec. It hints at the key might not be unique per device, but maybe per production batch or so. So yeah, maybe there's some possibility if you have, yeah, if you're good with hardware. I'm not, but yeah. So we have 2 layers of security. The EUICC has a CA preloaded, and it can, yeah, use that to establish the end-to-end encrypted channel. And yeah, that's basically also providing services to the host. Yeah. The eSIM profiles can in different packages or formats. So it can be, of course, the top one is the unencrypted one. That's available in the operator on the SMDP Plus. Then it actually will get encrypted and yeah, and MAC'd. So it's also integrity checked. And then the profile package binding is then bound, and it is bound to an actual device. So if you want to install it, you have to give your ID, and the ID of the device is then also bound. So you cannot install it to more than one device, right? So, and then it's actually delivered and to the device, and the device can decrypt it. So, so the EUICC, of course, has to provide some kind of secure way of installing it and managing that, so other profiles or so cannot just access the secret keys. The isolation is done via security domains, and the eSIM profile exists in the context of a dedicated domain. And the domains, they can have different privileges. ISDR, for example, is managing these domains, but the profiles are in a so-called ISDP, and they cannot access other ISDPs, right? I mean, bugs have been found in SIM cards to break the isolation, but yeah, I would say for very cheap hardware, like €1 or so, their SIM cards are quite nice. So, right, underrated technology. So, but yeah, even if you run something on the card, you cannot access other domains. But usually that's enough. So that's sort of how it looks like. Yeah. On a very abstract level, you have the mobile device, it talks to the card. On the card, you have a manager, ISDR domain. Then there's another domain even that stores the secret keys and can provide, let's say, encryption, decryption. And then you have some other security domains, and you have the ISDP, which is the profiles. So, so summary of this talk, I analyzed that, and actually I was not able, maybe other people can, but able to find, let's say, an obvious logic bug or blunder, and that doesn't involve some bribing somebody to get the keys, or finding some more implementation type bugs, reverse engineering the SIM cards, and so forth, right? So thank you for your time. No, actually not. So I don't stop there, right? So right, couldn't break that. But I mean, what's the goal here, right? Let's approach this more like in a different way. What actually do I want to achieve? I want to actually not. I don't care about the actual protocol. I'm more like a generalist offensive person, so I care about getting something, right? So the protocol is okay, but can I get around that, right? So that's then the approach. The approach is more like a red team. So don't care about the bugs themselves, just what do you want to do? And I want to research and explore and run my own stuff on eSIMs, right? So also there was this other, what I said, like vast thing, so because with all this infrastructure, there comes like, of course, new services, new implementations. I discovered that my laptop has like a FiboCom modem that has an eSIM. And yeah, one of the goals was we want an out-of-band C2, for example, right? Because the EDRs might monitor the enterprise network. So I discovered that on Windows, actually, they integrated in One Connect. They integrated eSIM in a way that you can just buy an eSIM on Windows. There's a default app or so, or even multiple ones, and operators can have their own. And there you get an eSIM, right? And the interesting thing is the eSIM provisioning actually on Windows doesn't require admin by default. You can enable that, but by default, at least on my Windows 10, it wasn't enabled. So any user can just deploy some eSIM profile, right? So as in, might not even have to bring a custom profile. We can just buy one and pay for it, right? So and then we deploy it on the victim's machine. So a quick overview of it's a bit small, but Windows sort of what it means, right? So in the Windows stack of eSIM, right? So on the top, yeah, you have like SM, DX, SMDP, which is sort of on the internet. Then you have the local service on the Windows that is an LPA service, talks to the W1 service, talks over the driver to the actual modem. And in the modem, there's the EUICC, right? So you have some new things. New things usually have some bugs. So yeah, to maybe recap, so for why is it interesting for us? We want to bring our own technology. We want to bring our own data connectivity to evade, let's say, maybe the monitored network. And also we want to have persistence. For example, it would be interesting to run apps on that. And also the question is it like a phishing vector, for example? Yeah, phishing is always a bit question. Of course, it's not like a kernel exploit, but it works. So, and it's actually a real problem. So that's, I think, what it makes it very relevant. So the eSIM, as I said, is like a smart card. It's a kind of HSM, and it can be dual use. So we can actually use it for, let's say, good things, like, I don't know, securing some stuff. Of course, the bad guys can also use it, right? So our goals: deploy our own profile, install some custom apps, and maybe find some vulnerabilities even, and also some nice tools that we can create. So deploying our own profile, I said like it's not possible, and that's actually true. So I'm cheating a bit. Not cheating in a bad way, because if you could also hack the operator's infrastructure, but that's obviously illegal, so we don't do it. That's a scenario to consider. We found like over 100 different SMDPs on the internet that have this certificate, right? So I'm not sure they are well secured. I don't know, but yeah. And second would be B would be to obtain the secrets. Yeah, we need a lot of hardware attacks or other leaks. I mean, it's potentially catastrophic scenario for vendors, right? If their keys are leaked, anybody could, provision stuff on their hardware. Or we just play by the rules and we just buy access, but not like as a full operator, so right. So when we want to deploy our own profile, we can pay for custom profiles, but it's not really cheap. But fortunately, for testing purposes, there's like a test profile by GSMA, and that can actually be deployed. It should not be deployed on production devices, but apparently it can. And the profiles, they look like this, also shown high level. That's like an ASN1 description. So yeah, they have a profile body. I think there was an ASN1 talk also in the conference. I didn't see it. But so it's basically you have to, for example, ASN1 is, and the interesting thing is, so the profile brings anything that's important in a SIM card, in a normal classical SIM card, of course. You have like USIM, you have like the secret keys, you have like applets, and so forth. So that's a high level overview of that. Yes, I will show how the test profile actually looks like. Let's see. if that actually works, and if it's actually so that's actually the test profile. You can just download it. You cannot just download it and install it. It's not that easy. Um, so, but of course it has an ICC ID. It has a lot of stuff. I have no idea what it is. Then there it defines the files on the SIM card, ICC IDs, IMCs, and so forth. And interestingly, it also defines the secrets like the POC and the PIN, and also some other, let's say, secrets. And did I find it? No, that's not it. It also comes with the applications that should run on this SIM card, which makes it kind of interesting, because running your applications on a production device, or yeah. So we will later see what actually applications are. Yeah. So here, for example, that's the USIM application. That's sort of built into the EU ICC, so it's just shared, sort of like a system library. But there's the IMC. But then we can also, yeah, there's also other things. One thing that's interesting, let me see if I can actually find it. Yeah, one thing that's interesting, for example, is there's not only POC codes, there's also other codes, like the test algorithm, which means that we can, for example, run like a 8 BTS or like a base station, and we could potentially have that thing log onto our mobile network if we would support that. Yeah, if you have a custom profile, we can also support other algorithms, of course. And then we have also keys that can be used for remote management, right? So that's good. And I will quickly show how that actually looks like when we deploy. When we deploy a thing. So this is on Windows. I used Windows, was quite convenient, and implemented a lot of things. So everything's integrated. So if you go to the cellular, you can like say manage your eSIM profiles. This is on the internal eSIM, and if you go there, yeah, it has an external internal SIM card slot. SIM2 is the internal one, and there's no profile yet deployed. But of course, if I have an activation code, you have to pay operators for that, but it's easier to get an activation code from the actual, let's say, with the test profile than running the whole infrastructure. You have to be certified. But that's for vendors. The interesting thing is, it shouldn't be, or the spec says, don't accept the tests profiles on your production devices. Yeah, that seems nobody reads that. Nobody reads the specs, I guess. However, if you have enough money, then you can also buy your own custom profile, right? So it's not really a security barrier for motivated attackers. It's a security barrier for researchers. So that's why it's nice that you can, yeah, install your own profile. And now we have our own profile on Windows. You can also do that on mobile phones, and yeah, that's actually quite nice, because with these profiles, we will see. Yeah, that's actually a setting, by the way, that would require you to be admin. But this is an unprivileged user on the Windows system. So yeah, we installed a new mobile. And yeah, if you are, say, in some environment, you have now your own network. Okay. So that's that. So we can deploy our own profile. And the interesting thing here is, I mean, yeah, that's great. We have our own profile, it's a test profile, that we have the OTA management keys and have the admin keys. Yeah, actually, I don't know where he is. Nikos, did anybody install that profile, that QR code that I showed before? Oh, I yeah, I hope it wasn't your work phone or so, because now we have like control over your SIM card. But we promise we will remove it again or so. We can delete ourselves. So yeah, yeah, that's interesting, right? So remote, these things can also be managed remotely, right? We can also pre-install applets on these profiles, but they can also be managed remotely. There's a limitation though. We don't have control over the EUICC. We have control over the ISDP on the EUIC. So we have control over one domain. In practice, it's actually all we need, right? It's like, yeah, we have control over the sim that is running, and it's like doing most of the interesting stuff. Yeah. So, and also it's a kind of HSM, right? So, if you cannot just look into it, right? So, yeah, and with new technology and implementations, and yeah, you have a ton of services. There's also, let's say, potential for new bugs. Actually, since I had at some point, I said to myself, I don't spend time on researching Microsoft things in my free time. So I actually so I let WinDGB attached to the W1 service run in the background of the profile installation. And yeah, it seems to be everything's a bit shaky. So during the research, things were crashing back and forth, right? So so now we got some kind of used after free, maybe. As I said, I didn't really research into it. I guess they have enough people that can do that. So that's basically the W1 service which runs the system, and that's triggered by the profile installation. So things seem to go wrong somewhere. Yes. So, but anyhow, so we have the profile on the EUICC. We have our own profile there. So what we can do now, since we have the keys, we can install our own custom apps. And there has been pre-known research on SimToolkit and friends. So there's for Sysmocom and SR Labs. Threats usually came from the direction of malicious operators or the attackers able to crack the OTA keys by attacking weird algorithms, DES and friends. That's actually something that is known. However, it was always a bit bound to being an operator or having a physical SIM card, and it focused a bit on the, let's say, on the actual attacking the SIM or so. But now we want to use it, so we can install custom apps to the UICC, remote provisioning, and that's nice, right? There's actually a ton of different technologies to install apps and manage these SIMs remotely. So they all like interconnected and not. It's completely weird. Maybe if you work on that for years, not. But for me, it was completely weird. So you have like GSMA remote provisioning, then you have the global platform standards, and they have some proprietary methods and whatnot. So. However, one method is, and since I don't run my own base station here, I will only show it using a so-called loader. But one way to remote install apps on your phone, right? So a person who scans the QR code, that's you. So it's only a video. So no, but it's the wrong one. Just a second. This one. So there's a loader that actually uses SMS simulates SMS because the modem talks to the SIM card, says, hey, this is an SMS. So this software basically can simulate that. This key is found in the test profile that you can see there. You have to set it. Yeah, it's a software from the SIM Alliance. There's also other software, but they are all incompatible and depends on the card. So this one worked best. You can also code your own if you have enough time on your hands. But they are basically sending commands to the SIM cards, APDUs that say like, hey, there's an SMS and this SMS that wants to install something high level. So we have an applet. We have written an applet. It's called evil.cap. And that applet is now installed on the SIM card. Yeah. And so we have that now on the SIM card. So to get these keys, and how that applet look like, we will see in a minute. So to get these keys, you can use different methods. So one method, of course, is you have a custom profile or your test profile, and the keys are known. If the keys are not known for example, for the global platform one, they use some challenge response protocols, and they're not exactly bad. They're widely used. There's different algorithms, ton of specs, and one of them I checked is SBC02. It's a challenge response. Simplified, basically the modem or the mobile device asks the card, so hey, I want to make challenge response. Here's the challenge. So the on-card application that responds with that, and they use like AES or triple DES or format times DES. But the AES and triple DES are like 16-byte keys. So yeah, that's if they're randomly generated, that's quite okay. But they have a shared secret key, or if you want to manage that, you would have to know the key. And then it's verification and response, and then also the host authenticates to the card. So I don't know why they asked the card first, actually, because quick analysis of this challenge response. So the card sends the first challenge. So if I don't know the key, I can ask the card at least for the challenge, and it's so-called cryptogram. And there's some diversification, so it's not always the same. It depends on some random value and whatnot. So some counters, so you cannot create like a rainbow table or so. But yeah, and it is a kind of key derivation from a master key. However, yes, triple DES still widely used, also AES. However, we can correct the 16 bytes if they're securely generated, but what if they are not, right? Due to the time, I will skip a bit. Wait to attack key is capture challenge response. Also the session context, that's important. You can try the default keys or use multi-rand. Multi-rand is like a quick tool that we hacked together. That's actually quite useful for a lot of security research things. And it's also not rocket science, but it's basically just a tool that is generating bytes based on a lot of insecure algorithms like RAND, libc RAND, Windows RAND, Borland RAND, and we actually had some success with that by cracking some Deathfire keys for electronic locks last year. But this is more the general implementation. So we will release that after the talk in this repository, and then you can exhaust the key space of the Unix timestamp in RAND in a few minutes or even faster, depending on how much CPU power or GPU power you have. And so it's actually feasible to try a few these algorithms and try like all the insecure keys, right? Yeah. So if you have these keys, then you can install custom applets, and that's what I did just before. The interesting thing with these custom applets is that you have they don't run on the device, on the mobile device, they run on the card, right? And it's actually complete hell to develop these, right? Because it's Oracle, JDKs, incompatibilities, the cards don't really play fair always, so not all applets run on all cards and so forth. So But still, it's called SIM Toolkit, use SIM tool, application toolkits, card application toolkits, the recent one, I think. And the interesting thing is, I mean, it's common knowledge the app stores on iOS or on Android, they're like pretty locked down, or they, of course, they find all the security vulnerabilities that are like submitted, not. But so on non-jailbroken devices, you cannot just install anything, right? It has to come from the App Store. However, the SIM card applications are not really under their control, so it only depends what APIs they implement. And the GSMA specs, they mandate APIs that have really extensive control over the mobile device. The vendors don't really implement all of them for good reason. Like, I think on iOS, you cannot just open the browser, whereas in other systems you can, apparently, from the SIM card. So, yeah. And this works with proactive commands. So the SIM card can send commands to the mobile device. So I've listed a few: profile download complete. There's a refresh command that like the mobile device should refresh some internal data or reset the SIM card, and it also displays text on the display, right? Or a prompt and get back the data, or send SMS. So they usually have some pre-installed applications, right, on the UICC that are shared, sort of. Then they can also run Java card applets. So you have applets on the UICC, and they run in JVM, bit subset of Java. You have packages, and from the packages you can have instances, and from there you can spawn applets. I will skip it. That's, for example, how such an applet would look like. Yeah, it's nothing new, but as I said, it's a bit obscure. I spent some time actually getting that to work. It's like a Hello World applet on the card. And yeah, so why am I am telling you this? Remember, eSIMs, you can bring your own profile. It's not the user has to plug into some physical card. So you can deploy your own profile on some device that supports it, even as non-admin, for example, on Windows. So you can install custom apps on that card. And if you have custom apps on that card, yeah, there are some interesting features, right? So, so one thing that we thought of, for example, is like an attack chain from an adversary that, let's say, has executed something on a mobile device, deploys an eSIM profile, and can use, for example, SMS as C2. And it's a kind of implant app on the SIM. So, and most of the research we've seen was more against the SIM cards, like, for example, Great Wall SIM Tester, or testing like a mobile device with a SIM card, yeah, and it involved often physical hardware. But a custom profile makes for researchers things a lot easier. One thing that we came up with, for example, is phishing with a toolkit. Yeah, might not be that interesting, but then maybe it is, because it looks like a system application, and the SIM card can send SMS without the mobile device showing anything about it. And we wrote a kind of further, or let's say, test app that can try to execute all the, or find proactive commands and do that cause things on the host, right? And actually, I mean, if you're into fuzzing, you would say like, yeah, that's nice. You run some fuzzer or something on the Java card, and it's super slow and has like whatever 10 iterations per second. So I dump the firmware, or I have the firmware, I emulate it, fuzz it much faster, and that's true. Or I have a physical test, UICC's physical test SIM card, and that will do that much better than some weird Java applet. That's also true. If you can do that, that's great. But of course, this approach is super flexible. So because a lot of these eSIMs are like soldered chips in some devices. So if you're not a hardware pro or whatever, don't have access to these devices, yeah, you cannot really get to that chip or to the firmware. But with the test profile and custom applet, yeah, you have access to this attack surface, right? Which is interesting, I find. So, so we can target a broad range of devices. So of course there are limitations. Yeah, proactive commands use a workaround. So it used to be that the host sends a command and there's a response. So the SIM card cannot actively send something. The host has to poll. And this was solved by proactive commands. So when the host has something and the SIM card can say, hey, I want you to send a command every 1 second, it can poll and makes the communication still a bit slow, but at least in a predictable interval, there's some command coming. And yeah, the cards seem to filter out broken APDUs, and of course you don't have coverage instrumentation. Yeah, but as I said, it's flexible and generic, and that makes it nice. So I will show a quick demo. It's actually the demo is actually the heading subject is a bit wrong. It's actually a combination of the different things as in the slides before, so it's not really fuzzing a lot, but it's showing something interesting. I ran that on my iPhone, and if you see here, oh, I need to unlock it, yeah, the passcode, but actually that's not the iOS dialog you see in the background. It was actually the SIM application, the SIM card application, right? And I will skip through the details of that, how it actually works with the events, but the SIM card application registered to all the different events, so it will pop up, and it can pop up anywhere. And when it pops up, it actually has full control over the UI. I wouldn't say it's a vulnerability. I think Apple asked for if I have any vulnerabilities. I mean, it's still a phishing scenario, and it's working as intended, right? So and specified. But yeah, this is the SIM application, and the SIM application basically never lets you out, right? It fuzzes all the different commands. So if I wanted, the phone might be unusable until you factory reset it, yeah. But of course, you have to install like custom app. So. But that's quite nice, and it's sort of bypassing, of course, the other restrictions on apps, like controlling who installs what, because I can install this app using an eSIM profile that I can scan with the QR code or so, right? So. Yeah, okay. There we are. Okay, another thing I mentioned before, how can we use it for offensive? Out-of-band C2 via SMS. I think that was the most straightforward thing that we came up with. So in the red team engagement, like let's say we got scenario, we had temporary access to something, we executed the payload or physical, let's say it's an air-gapped or so. So access is only temporary, so we cannot rely on the internet, and also, yeah, EDRs monitor the TCP, DNS, UDP, anything, right? So one solution is we bring the own connectivity and use an out-of-band channel, right? SMS, for example. We could also use mobile data, by the way, but yeah. And this is how it looks like. So Nikos from Psy was so kind to develop a quick POC. It's not a full C2 or something. But it's like on the right you see sort of the victim doesn't have internet access. On the left you see actually the controller, and yeah, it specifies the numbers. So they only communicate via SMS, and it's like encoded. And yeah, on the right you see actually in Windows, if you install that app, it shows the SMS, but otherwise it doesn't. And actually then, yeah, you have a full C2 over SMS. There's a bit of lag on it, but the thing is that even if your system is air-gapped, and for example, this Lenovo here has an eSIM by default, if I put that in my super secure network, we can still reach it, right? So we can still reach it because we brought our own connectivity, our own network. So, and as you see, yeah, we have like a nice C2. Of course, you can now encrypt it, use Sliver or whatever. C2 using C3, implemented in C3. That's actually yeah, what's possible here. So that's a POC. There can of course be a next level implant. It can also be don't see it in that negative way. You can also use it for example, when you do adversary simulation and you want to have ensure the customer that you don't, uh, open the floodgates on their network, right? As I said, it's like an HSM, the SIM card, so you can. It's like a protected environment. If you don't have the keys, you cannot access it. Of course, for defenders, that's a bit of a problem, but for attackers, of course, or for people wanting to run something securely, that's also good. I mean, defenders and attackers care for security. So if you run things on the SIM card, the good thing is that the SIM card also has like AES, it has proper crypto, asymmetric crypto. It can talk to the modem, send some SMS. You have applet business logic. Yeah, it's not super powerful, but you can control like have to implant business logic on that applet and only a stub on the host, or you have like a 0-day on the host that that the applet can somehow exploit. So you have a very, very stealthy implant that nobody can really reverse engineer unless you get somehow control of the EU ICC management devices. I don't think Lenovo or Fibocom will give that to you, even if you're a larger enterprise, but I don't know. If you're like larger enterprise, maybe you have EU ICCs that you can control, right? So you can, but still then, it's very hard to get an app out of the, let's say, from the card if it was installed, right? So at least it's not really documented. So it's a bit of a problem. So you can have persistence in the SIM card, sort of. So, conclusion. So, the research into eSIM opens like a vast space and a zoo of technology. So, I always was a bit like, okay, I want to go deeper here, but in what time? Or like, okay, then I can only do that. So, I think what I wanted to show is that you can find new applications for this technology, good or bad. Of course, I have the offensive perspective, so red teaming and research. There's a way to actually do research on that without being an operator or GSMA signed up, and I think that's important because otherwise there are organizations with a lot of money that can do that, but single researchers can't. So that's never a good situation. And the environment is very tightly controlled. Yeah, but yeah, there are some ways. So, and it's possible to follow the rabbit hole, right? So I had a few weeks of time for research, but there's so many things. But you can see that even as a single person, or if you have some trusted peers, some trusted colleagues, you can still reach something. And and the mobile platforms are like constantly evolving, making it I find interesting for us. So, and I could have, I think, done 3 talks because I didn't touch APDUs and things at all. But yeah, we only have so much time. So thank you very much. Yeah. We will release some tools in the coming days. So the test suite applet, the global platform card key brute forcer, or how to brute force it in the multi-rand, and POC for the SMS C2. So.